On this one, what kind of problem does this look like?
It looks like something I
Shh. What kind of problem does this look like?
distribute.
Distribute. So when we do like a times a, what do we do with the exponents? Add. So 1/2 plus 3/2, so add the numerator, is 4/2, 4 over 2, which is just 2. And then the 2 on this one, and then 1/2 plus 1/2 is 1. So this is just a to the 1, or a. Can we do anything else? No. That is all the end. And there's no A, B's, or C's, so that was yesterday's assignment.
Sick.
Okay, same thing on this one. So what is x to the negative 1/2 times x to the 5/2? X to the 4/2, which is, again, x squared. And then this is very much like the last one, isn't it? Minus 2, and then negative 1/2, 3/2. What's this going to become? Basically, negative 1 plus 3 is 2 over 2. So it's just 1 again. So it's almost the exact same answer as number 17. Actually, it is the same answer, just x's instead of a's.
At least it's not hard. Yet.
Yeah, how come on?
Yeah, the next one looks hard.
I just jinxed it.
Donald Trump. Why couldn't Donald Trump just save us?
Did you look up that video yet, Grant?
No, I don't really feel like I want to see someone on the toilet.
I would say it's right up your alley. You can't really, it just shows her face.
Hope is like just over 45.
Say it was Donald Trump.
Yeah, she's just over 45 pounds. She's such a small kid.
You're 45 pounds?
No.
Or dude,
That's like half of Skylar.
That's pretty tiny.
That's pretty astronomical.
Who weighs more or less, you or Skylar?
Hope weighs less.
Hope was like 90
She
something.
barely hits the
She told me she was over
She's like
100.
100.
I'm 100 now.
Like a month ago, she was like 98 or something.
No way.
I thought you were
That's crazy.
You told me like 2 years ago you got over 100.
Yeah,
And then when you got like
do that.
not well, you went back under 100.
yeah.
And then you went back over again.
At the hospital, I was at like
For the kid, last time
92. 'cause I couldn't
Yikes, that's scary.
Bro,
Last time I was under 100.
25.
You probably look like a,
Third grade. I don't know.
Stupid ugly girl.
no, what's the concentration camp person?
Alright, we're not talking about the same. That's not what it's conversation.
70 pounds.
Are you calling Hope and Frank?
Like,
And Craig.
like half 7 grade.
Okay, so,
No, 7th grade, I finally got the grade. Like, it was bad.
Willow's malnourished.
No, I was skinny. Like,
okay, shh. What would we do on this problem?
it was bad.
Subtract.
Okay,
Thinking on the top.
it's the same as this was multiply, distribute to multiply. This one we're distributing the divide. So when we divide, what do we do with the exponents?
Good question.
Subtract. Up here, when we were multiplying, we added the exponents. So when you divide the x's, you subtract their exponents. Okay, so 1/2 minus negative 1/2. You gotta be careful. 1/2 minus negative 1/2 is what? No. Minus negative is plus. So 1/2 plus 1/2 is 1. So this first term will become x to the 1, or just x. Okay, this one would be negative 1/2 minus negative 1/2. What would that be? 0. Okay, and what is x to the 0? 1. And what's 1 times 2? 2. So it kind of just goes away.
Is the next one gonna be like last time, which is the same answer?
Oh, I doubt it.
It's a smidgen different.
No,
But it's not, it's not.
Not the exact same answer.
Sigma.
Actually, it is. Okay.
You should do Mojo instead.
Wait, are you saying it's like the same?
Wait, so
You should do 20.
If I give you $40, will you give me your answer textbook for 5 minutes?
Whoa.
Grant, you do not have to do that.
I do. I wouldn't take it for $1 billion. $1 million billion.
But that's a lot. Yeah.
No, it's not. I told Skylar I'm freaking rich. I won't take any money.
Are you sure of that? I was supposed to be Was it you?
No, I heard it. I didn't.
I was
I'm not that tempted by money. Okay, anyways, so on this one, 2 divided by 2 becomes 1. And then 1/3 minus negative 2/3
One.
is 1. So it's into 1.
Oh.
And then over here we have negative minus 4 divided by 2 is minus 2. And we have negative 2/3 minus negative 2/3. 0 into the 0 just goes away. So it is actually the same as 21.
Let's go.
What's your favorite Taylor Swift song?
I don't. It does not. NA, not applicable.
You said you listen to KSI.
I'm confident.
From the screen to the.
I never remember in my life like having a Taylor Swift song in my head.
I am confident that you have a favorite.
Everybody loves Think of It, bro.
Everyone has a favorite Taylor Swift song, even if they don't.
No, Think of It.
I would have to think of like my least not.
My dad calls Taylor Swift the devil, and he has a favorite Taylor Swift song.
I don't have a favorite, but I could probably think of one. But
Oh, shake it off.
I don't really like.
Mr. Jordan, can you say itchy knee?
What?
Itchy knee?
Yeah.
Why is that Japanese?
Arigato.
They're gay.
Oh.
Why was that hissing?
It's bubbly.
It's
Sparkling
really just
Sparkling water.
She likes
Clean water.
she likes to jump
You
off
guys
cliffs.
Last time I heard that sound, it was a Sprite.
Why don't you pour Sprite in the sparkling water container?
Because it doesn't look like sparkling water.
It does. It's like the same.
It
Absolutely does.
It's just water with bubbles.
I can clearly
Same
Sprite
as
has
Sprite.
a lot
That's what
more-
Sprite looks like.
No, Sprite has like a lot of bubbles.
Yeah,
just-
it has like a lot of small
Also, I
bubbles.
hate Sprite.
Then just drink it really, just shake up the Sprite and then to get some of the
I
bubbles
think
in.
it's good. We should do
Or just drink it really fast so no one notices.
So when you try to chug it and then
Oh,
it
yeah.
Sprite, bro?
It gives me a headache
Yeah,
though.
Taylor do
It's not gonna bubble up.
I've never felt.
Okay, 25. What do you guys? There's actually a couple ways we could do this. What are you guys thinking?
Distribute first.
You could distribute and then divide both. There's actually an easier way.
Cancel.
You could just divide this term by this, and then it will still kind of get distributed when you distribute the remainder to that, if that makes sense. Like, you can reduce this. Because this is basically because this is a multiplied value, you can cancel out with this divided value. Yeah, so 2 divided by 2, that'll go away. And then what's 1/3 minus negative 1/3? Yeah, it's 2/3. Yeah. So this is n to the 2/3 times this, and then you do have to still distribute. Yeah. Okay? Yeah, but then you still have to do this. So we have 3, and then 2/3 plus 1/3 is 1, into the 1. And then we have 4, 2/3 plus 4/3 is 6/3, which is 2. Hey.
You sound like one of those door hinges that like creak when you laugh.
Need some
Laugh again.
WD-40.
No.
Do you use W40
Door
on
hinge.
Anything that has
Ask him what he was
Yeah,
doing.
anything
If
that
he's
greases,
saying it for
kind of greases the groove a little.
I only like put on like parts,
Like-
like parts and stuff.
Mr.
Or like
Jordan,
rusty things.
are you staying home for Christmas?
no.
You want to visit your family?
Yeah.
This is the only class where like
Stop. Okay, what do you guys think on this one?
I'll forget
do
away.
that thing and then you do that.
You do what we did yesterday.
Okay, exactly, yes. I would turn this into exponential form instead of radical form. So this, the top is 4a to the what?
3/2.
2/3. And the bottom is 4a to the what? 1/6. It's kind of like an invisible 1 right there. So 1/6. And then these are both 4a's, so we can just subtract the exponents. So, yeah, we need a common denominator. So if I multiply this by 2, this becomes 4/6. So it's 4/6 minus 1/6,
Oh.
3/6, which is 1/2. So if you wrote this, I would say it's okay, but guess what the book put? Probably, I don't know. Because, right, because they start in radical form, they're probably gonna end in radical form.
So you wouldn't count off if we did the other part.
This is okay, yeah. Unless they tell you put it in radical form. I guess that would be the only problem. Alright, you got one more of those? Nope. Next section.
No.
Okay, you guys might remember this from last year, maybe, I think. I'll give you a shot. Anybody think they might know how to do this before we do it?
It was the weird thingy where it had like the boop, and then there was a little exponent, and then equal boop.
Okay. I didn't get the boop boop, but
I don't know.
The
Is it the
answer
log?
is 2.
the answer is 2.
You're great, Lisa.
Yeah.
I know like when there was an exponent, we used the log.
X squared
Okay.
equals 2 to the 6.
There is a way to solve these with logs, but logs are more for more complicated versions of this, I guess. We are going to do logs this chapter also, or actually no, that's chapter. I can't remember if it's this or the next chapter. Anyways, the way that they wanted us to do it though is you can turn them into the same base. If the bases are the same, like 8 and 2 are the bases, then you can solve the exponents have to be the same. So how could I turn 8 into a power of 2? 8 is 2 to the what? 2 to the third. 2 times 2 times 2 is 8. So if you turn 8 into 2 to the third, it looks like this. Then what do you do with the exponents when it's like a power to a power? You multiply, you just put them together basically. It's 3 times that. Okay, so once the bases are the same, if these two things are equal and the bases are the same, that means the exponents should be the same. So 3x equals 6. Therefore, x is 2. Yeah, logs can solve this, but logs can solve messy ones that you can't just play around with. Okay, 30 and 32 are both 9s, and, okay. Like on 30, 81 is 9 to the what?
2.
9 squared, so just turn the right side of the 9 squared, and 4x would have to equal. Anyway,
34 looks hard. Real hard.
okay, so this is kind of the same trick because it's an 8 and a 2 again. It's a little bit of a repeat. So 8 is 2 to the third. Okay, what should we do about this though? Distribute, that's right. Just use the properties that you know. So it's 3x minus 3. So therefore, now logs have to be this chapter because this is the chapter with exponents, so this is the log chapter.
But that's gonna be for a while.
I think I've worked it out for enough. Maybe next Friday. That's a long, kind of a long time.
So you know what all this reminds me of? So you know the no one's gonna be on time for, you know, she stands up and she's like, no one's gonna, you know.
That was a really long for such a little problem.
Full West, expelled.
Life is cinema.
Dude, I was like, you
Yeah.
know, like,
Yeah.
oh, and also remember that one time when I was talking about the
Sometimes I
policy,
feel
I
like
said the well,
getting my chest
thing?
because I got like a
Do you
little
actually
bump.
remember?
Please,
So you know how the prophecy
Frank,
goes,
you better not do something bad.
please,
Or it's falling on you.
Okay, on 34.
But remind me,
Okay, do you guys know what 9 and 27 have in common?
5,
Right.
3,
No, right.
They're both powers of what?
9, 3.
3.
Idiot.
3. But it doesn't say they're both powers of 3. But the 9 is on the bottom. So that would be like 3 to the what? Negative second. Okay, because the negative exponent flips it upside down. So the right side, the 1/9 becomes 3 to the negative second. And the 27 becomes 3 to the... 27 is 3 to the what? 3.
10? No. Unless it's like a little, like.
Okay, on this one, what can we do about this mess over here? The ideas?
Calculator.
Can we just do 2 times 4?
No.
Mm-mm.
Wait, you could
You gotta
Make
do
it 4
the
to
exponents
6.
first and then you multiply them together.
Could you make it 4 to 6? Or no?
Okay, 4 is 2 to the what? 4 is 2 to the what? Second. What do we do with the exponents here?
If you come to my house,
Shh, hush. What do we do with the exponents right here?
Multiply.
Multiply. So it's 2 to the 18th.
Then you,
Add. Okay, and of course 8 turns into... Come on, this is the third time. Third. So this will be 2 to the 3x. So 3x is 25, x is 25 thirds. I'm going to add on 37 and 38 also. you still on the front of the page though? Sorry,
Why are you complaining?
you can put it on the back. It'll ruin my perfect page.
Right before us.
Okay, 37.
Yeah, it's zero.
A house bought for $50,000 in 1980 was sold for $150,000 in 1990. That is a good profit. To the nearest percent, what was the annual rate of appreciation in the value of the house? Any ideas?
A tenth each year?
Huh?
A tenth each year?
No,
Oh, shoot.
it's more complicated than that.
Oh, okay.
Because, okay,
It's like a third.
actually, let's talk about this for a second. If I increase 100 by 10%, what do I get? 110. But then if I increase that by 10%, what do I get?
Don't you get like 120?
121. Because 10% of this is 11. So every year that it's going up by 10%, it's not increasing by the same value. So it's not that simple. The value that it goes up would go up. That's kind of how interest works. You're increasing on the increase. So it actually goes up higher. Anyway, what formula should we use to figure out 37? $50,000 house, a few years later they sold it. How many years later? 10 years later they sold it for $150,000. What was the annual rate of appreciation? Like what percent did it increase per year over the years? We used this formula yesterday.
It's like the
Yeah.
plus R.
This is for growth rate or
T.
decay rate or whatever. So what would go right here? Huh? $50,000, the original amount of the house. What would go right here? Yeah, trick question. We don't know. That's what we're trying to figure out. What would go right here? 10 years. And then they said 150,000. Where does the 150,000 go? Right. It's going to end up at 150,000. It's kind of like the answer to yesterday's. So how do we go backwards? Divide by 50,000. 50,000 is multiplied in the parentheses, right? So we can just get rid of it by dividing by 50,000. I think we might have done this a little bit last year, maybe. You guys think so? Okay. What to do? What to do? What's the opposite of the 10th power? The 10th root. These are not all called square roots. 10th root. The symbol is called a radical. Square root is the most common, but anyway, this is the 10th root. So to get rid of the 10th power, you take the 10th root. So over here we just have 1 plus r. Over here, this is a very tiny decimal because it's like what times itself like 10 times equals 3. So it'll be like 1 point something small. So for now, I'm just going to leave it like this. Okay, what would we do to solve this for r? We're almost done.
Sorry, is it
Subtract.
Yeah, if we got lost right there, I would have been very disappointed.
Okay, I'm sorry.
Okay, so now what does R stand for? R stands for the appreciation rate of appreciation, like what percent the house value is going up over the years. So would we leave the answer like this? No, you put it in the calculator, change it to a decimal, change that to a percent. Let's do like tell me like 4 decimal places.
0.1161.
Okay, what does that mean? 11 11.6%. By the way, that would be a crazy appreciation. Like, that's going up very quickly. When we had, you guys know, we had inflation really bad like 3 years ago. The highest it ever got was like 10%, which is really bad. But that's, like, if something's going up by 10%, it'd take like 9 years for it to be half its value. If that makes sense.
Wait, what if we can't get the number down to 1 plus R on 38?
Or to be double, what?
What do we do for 38? Because we can't like get rid of all of it. And there's like still some stuff left over. Like for the square root part.
Which number is it again?
38.
Oh, 38 is the same thing.
Wait, yeah.
Can you divide 140? I thought you could only divide by like 14.
You do, yeah, you do 182 divided by 140 to start with. It's not as,
Oh, you just divide by 140. Oh, my bad.
You mean 6 to 8, 5 to 8?
Well, don't you, isn't this one right here, and that one's there? Where's the data?
didn't it start at 140?
Look!
Yeah, 140 was 4 years, that was the starting price 4 years ago.